Hello everyone and welcome to follow this presentation. My name is Tero Kaarlela. I am working at CENTRIA University of Applied Sciences as a lecturer and a robotics researcher. Next, I will be presenting our implementation of a cyber-secure remote-controlled industrial robot cell. Flow of this presentation is following. First, a short introduction of CENTRIA, so you know who we are, where we are and what we do. Then I will explain our need for remote-controlled robot cell. Next, we will move on to detailed description of our solution. After detailed description, we will look at other possible ways of utilizing this solution and some thoughts about investments required in order to utilize our solution. And finally, short conclusions of this solution. CENTRIA is a University of Applied Sciences. We have 3 campus areas in Finland, one at Kokkola, one at Pietarsaari and one at Ylivieska. Our main job is to educate engineers for various industrial sectors, in example industrial management, chemistry and machine engineering. CENTRIA also has research and development branch to keep on track of current technology trends. Currently, we are one of many research partners in Horizon project called TRINITY. Through TRINITY, we have been able to collaborate with other European universities and to share knowledge in topics of robotics such as safety and cybersecurity. Our third focus area is to provide measuring, 3D printing, marketing and robotic simulation services in order to support local companies. Our need for remote-controlled robot cell rises from our robotic training workshops. In the past, we have been offering one-day-long on-site workshops for student groups during our robotic courses. Practical laboratory exercises offer good and efficient way of learning skills in programming and controlling of robots. On-site training has only one weakness. It is not possible for students living far away from our campus. For years, we have been looking for ways to offer also online students a possibility to participate in our robotic workshops. Robotic cell with ability for remote control is possible solution to this problem. I will now move on to describing solution we have implemented for this problem. This drawing describes principle of this solution. On the right, we can see isolated network that has been set up only for the purpose of remote controlling our FANUC industrial robot. To guarantee cybersecurity, this network is isolated from our university network and only has 2 clients. First one is FANUC robot controller and second one is a webcam with pan, tilt and zoom capabilities. Robot and webcam are connected to ASUS router that has 4G mobile broadband connection to internet and built-in OpenVPN server. On the left, we can see remote control location having a workstation with OpenVPN client and robot online simulation software. OpenVPN server or remote control location is not needed, only OpenVPN client, connection to internet and preserved OpenVPN certificate. This is enough to form a VPN tunnel between remote control PC and our private network for robot remote controlling. I will now explain how this works in practice. We have created an Outlook calendar for our FANUC educational robot cell. Students can book an appointment with our FANUC robot for 2 hours. After booking, they will be provided with OpenVPN certificate and instructions on how to install OpenVPN and connect to robot cell. During 2-hour session reserved for them, they can remote control this robot cell manually and create and run programs with it. They have live view of robot cell with pan tilt zoom webcam located inside robot cell. Session will be recorded for reporting purposes. After each 2-hour session, robot factory image will be restored and new OpenVPN certificate will be created. Then academic cell is virus-free and connections with previous certificates are no longer working. This way we can provide safe and secure 2-hour session to next students. Let's have a look at other possible application scenarios for this implementation. This is another example for education and training purposes. Example shown here is a milling robot with a remote control capabilities similar to previous example. Usually we have groups of about 20 students participating on our robotics courses online from distant locations in Finland or some other countries. Some of our students have participated from Norway and India. This exercise begins by creating simulation model of our existing robot cell. End result of this exercise is a working digital twin of robot cell. This offers students to gain hands-on experience of digital twin concept and also controlling robots. On the left you can see same view our students will see, simulation software and live webcam view from actual robot cell. On the right you can see robot cell in our laboratory. Our third application example presents possibility for equipment sharing between organizations. In this case, we have online borrowed robot welding cell that is physically located at UIT in Narvik, Norway. We do not have TIG welding cell here at Ylivieska, so we have borrowed one at Norway. On the left you can see view from Norway, and on the right you can see our view from our lab. Let's have a look at scale of investments for this solution. Hardware investments range from few hundred euros to thousands of euros depending on hardware invested. 4G router presented here costs about 200 euros and webcam is around 100 euros. Costs for mobile broadband subscription is about 20 euros per month. Robotics software cost is about 3000 euros per license and OpenVPN client is released under free GPL license. Solution based on 4G mobile connection and OpenVPN presented here are simple way to provide isolated VPN access to robot cell. Method is cost effective as total costs excluding robot and simulation software is only about 2000 euros. Solution demonstrated is also scalable to many remote control and monitoring purposes such as CNC and also other machines. Thank you for listening and paying attention.